Okay, fixing the mistakes. So 7 gave me minimum minus 384, minus 384, minus 34, where at 7. And then the 116 gave me maximum at minus 3. That's 116. And then if they ask you, what is the maximum value? You will say, oh, maximum value is 116. And where it happens at x equals minus 3, like so. Okay, now it's correct. So definitely that was not very good. Here's the problem. And now you see, then I will say this classical phrase, can you do your test without messing up like I just did? Basically just pay attention. And that's why it's nice. If you have time left at the end, which I hope you did, I just checked people took 1.5 hours for the test. So hopefully you will have half an hour left to check. Maybe redo the problem. Don't try to find the mistake. Usually it's very hard to find a mistake. Redo the problem completely instead. That is much better. Okay, very good. Now we're gonna go to all those critical points, min, max, blah, blah, blah. Let's do that. That is basically the biggest theme or topic of this exam. Let me go to number. So I'm talking about this review. Let me go here. So we just did number 3. Here it is. And I do have video specific on number 3 because whatever has a circled in my solutions, whatever has a circle, yellow circle, then it has videos. Oh, this time it actually loaded. So number 3 had a video. I just wanted to explain it again. And so on. So I'm following this and a little bit more than that. Now I want to go to number 3, number 2, but instead of number 2, this like product with E, I will go to 11 because 11 repeats it. Here you go. 11 repeats the whole thing, but it asks everything. So if they ask you to go up until inflection point, let's actually spend time and do everything. This is where the fun starts. Number 11. Number 11 has a function. So, y equals 9 minus 2x e to the 3x. Can you do everything? So you remember in your homework, you had those long problems. That's what they put in a test. So they want to make sure you can repeat those problems, which means find intervals. Well, find CPs, critical points or critical values. Then increasing, decreasing intervals. Then you find second derivative and you find concave up and down intervals. And then you find points of inflections or inflection points. POI, that's all American abbreviation, points of inflection. Let's do it. So that's going to be a nice practice. See, it's a product rule here. So you know how to start to take derivative, but the first step already uses product rule. That means you need to be very good at product rule. Hope you are, because everything relies on that. If you make mistake right now, everything will be wrong. U times V, derivative of U is minus 2 times E3x plus 9 minus 2x times e to the 3x times 3. Remember, chain rule says times derivative of the function inside. But what is the function inside? For exponential function is that 3x, it's an exponent. That's what they mean here. Now, you set it equal to 0, and this is where you stop, right? So, no, don't be stuck. Just believe in yourself. You can do it. Just a little bit concentrate on that. Try to distribute things. You could factor things here. I would do that. But you can also distribute things and see what happens. I would factor the repetitive exponential function. Then it will be, so the goal for step 2 is y prime equals to 0 or d and e. It will not be d and e here because exponential is continuous and all those little polynomials are fine too. So it exists everywhere. E to the 3x minus 2 plus, let's distribute quickly, 3 times 9, 27, minus 6x. equals to 0. Well, guess what? Exponential function cannot be 0, if you remember that. Can you imagine e to anything that gives you 0? No. So from these products, you only need to check this guy. Looks like it doesn't look correct. Minus 2 plus 27 minus 6. Okay, looks okay to me. So you just need to solve the second part, which is 25 minus 6x equals to 0, which is x equals 2. I don't actually have notes on that, so let's be careful. 25 over 6. That is a critical point. Yes, actually, I don't know. I need to check if it is in a domain. And I already mentioned that. Yes, because original function has domain, because domain is minus infinity to infinity, or domain of the original, domain of y. You're not supposed to include things which are outside of the domain. Or you're supposed to include vertical asymptotes because they sometimes break the pattern. That's called point of discontinuities. Even if there's a vertical asymptote and something happening here, you're actually supposed to include that because it might have changing the patterns of concavity or increasing, decreasing, and so on. But in this case, all points will be good. Okay, so we found the critical point. Answer, that's what you type in, right? You type in the answer 1. Answer 1, critical point is x equals 25,6. Yeah, but that's critical value. So what's the difference? Value is your input, right? Point requires x comma y. So you're supposed to plug it into the original 25 over 6 comma, and then whatever is the original will be, let's say, f of 25 over 6, because this is f. And you carefully calculate it. So plug into the original. If they ask you for it, plug into the original. As always, I plan after the exam, go back and see if you guys forgot, if you guys put it this instead of both and so on, and I'll give you partial credit. But if you try not to forget. So you know what's going to be the answer? It will be 9 minus 2 times 25 over 6 times E 3 times 25 over 6. And guess what? Nobody requires it to simplify. I made sure in the settings that WebWork accepts not simplify answers. So value CV versus C point. That will be both are correct answers. I'm just gonna reinforce the idea that it depends on what amazing and very logical WebWork is asking every single time. Is always different. It's so annoying. So that's kind of the problem here. Answer 1 is done. Let me put yellow. Now continue. Step 3 is intervals. Increasing, decreasing. Well, that's when you perform first derivative test. Your favorite one. First derivative test. How many people, they teach it differently? You can do a table. I do a sine line. Here's my sine line because I call it sine line because it indicates the sign of the derivative, right? Sine line for the derivative. You put critical point here, the x equals 25 over 6. And now you have everything before and everything after. The critical point divides behavior of the original function in two universes, basically, before and after this point. And then remember, if derivative is positive, original function is increasing. If derivative is negative, original function is decreasing. If it's hard for you to remember, what are we looking at? Sine of what? We're looking at sine of the derivative. So you just quickly find test points, some kind of easy test points. It's nice to use 0 and 1 when you can. In this case, I would do 0 and 10. You can do 0 and 100 or a million. You don't need to know the exact number. You plug it into the derivative to see the sign. Well, where's my derivative? Let's put it in the box to make sure we know where to plug. Here it is. So e to the x is always positive. That's the whole point. So you don't be bothered by that. You only need to be bothered by the sign of 25 minus 6x. Well, when x is 0, obviously derivative is positive. When x is 10, it becomes too big for 25 and 100. Too big and negative, right? So minus. That's how I see it, at least. And it's my notation. This is, if you watched my video, which is, again, you don't have to. Then you know this is how my notation works. And I really like it. Students made much less mistakes when I explain them the way I see. Then I'm changing the color and I'm writing down what original function is doing. Original function is increasing where derivative is positive, which is from minus infinity to 25.6, decreasing after that. So now it's like very visually, you can answer, I'll put it in red this time. Answer 2. F is increasing on minus infinity 25/6, decreasing on 25/6, comma, infinity. Yes, so, and you don't include the point. Do you know why you don't include the point? Because at that point, it's neither increasing nor decreasing. At that point, derivative is 0, right? So derivative is 0 here. That means original function is not increasing and not decreasing. So you're not supposed to include. Don't call it a name, which it's not either. Example what I just want. Okay, so we finished with this first part of the first derivative test. Everything was about first derivative till now. And now we move into the second derivative because we want to see concavity and inflection points. Concavity has something to do with second derivative. And that's how you see this whole thing. It's divided into 2 parts. First derivative is required to find second derivative, but also there's a whole topic, let me put it, whole topic about first derivative. Here you go. Lots of stuff is about first derivative. And then lots of stuff is about second derivative, concavity, inflection point. Second derivative need to be found first. So I would rewrite what was the first derivative. When I factor it, remember? It was, well, now I don't know. Oh, here it is. Actually, it's not. My notes are so not helpful at all. Nothing is there.
Are you talking about 3 to the, I'm sorry, e to the 3x times, in parentheses, 25 minus 6x?
Minus 6x. Oh, thank you so much. And now I'm different. So I will write down. First derivative is this. Thank you very much. Second derivative is product rule again. Derivative of e to the x, e to the 3x is e to the 3x times 3. Reminding you that's chain rule. When you differentiate, you multiply by derivative of the inside function at the end or at the start if you want. Copy plus e to the 3x times derivative of this very nice polynomial, which is minus 6. Nice. So that's my answer for the second derivative. And I'm going to repeat the same idea because we need to find zeros and denies again. There's no denies here, but let's factor out, just like before, e to the 3x. It's actually very nice to work with e to the stuff because it repeats all the time, so it's very convenient. 3 times 25 is 75 minus 18x minus 6. Wow, looks correct. I'm very impressed that suddenly I made it well. Not 0. E is not 0. So we just need to figure out what is minus 18x plus 69 is doing. Well, x is 23/6. That's what in my notes it says. Okay, looks not too bad. It's a 69/18. Okay. Again, yeah, no. Okay, good. Then we do second derivative. This might not be a POI, so we don't know POI. Need to check. So don't immediately assume that is the point of inflection. It must change the sign in order to have point of inflection from plus to minus to minus to plus. Sign of what? Sign of second derivative. So let's do this second derivative test. Also your favorite. That is step 5. Step 5. Second derivative test, like so. And it's going to be, again, I do the sine line, and this time I put second derivative in it. So before, you see, that's kind of my notation. I'm putting first derivative to remind myself it's a first derivative sine line, but also it comes from the title. First derivative test checks the sign of the first derivative. Second derivative test checks the sign of the second derivative. So I put this point I just found, 23/6, and I'm checking the sign of the second derivative. And if you, again, I like having some funny memorizational tricks, because sense of humor officially apparently helps people to remember stuff. There's a whole like psychological study on this. I'm a friend of the people from psychology department at ASU, PhD students. And apparently there's like a whole study about sense of humor and memorization. So if the second derivative is positive, then the original function in smiling, the original function is smiling, then guess what? It's concave up, concave up. And also, second derivative test, if you remember, also uses this test to indicate minimum and maximum. Well, because it's happy, it has minimum at the tongue. And then if second derivative is negative, then it's grumpy, like so. Then it's concave down, concave down. The original function, concave, is concave down, and it has maximum at the nose, like so. So to be honest, it's funny that people actually draw these little things in my tests, in-person exam test classes tests, and it's just very cute how they draw it. But honestly, really helpful. You're gonna have the same thing in calculus 3, but a little bit more complicated. There will be a third version, plus and minus, and it will be like this. And I would say that because it's a pirate, he lost one of the eyes, and that's it's seriously though, and that's why blah blah blah. So it will be calculus 3. It will have a third option because it's 3-dimensional. So I like it. Basically, that's my style. Silly but productive. That's exactly how my education could be described. Let's check. You plug it into second derivative. So I would recommend putting it in the box. Here it is. Factored or not factored form. Again, E cannot be negative or 0. So I don't have to check the sign of that. I just need to check the sign of minus 18x plus 69. Well, use test points, 0 or 10 or 100, whatever you like. At 0, you get 69, and I don't care what the number is. I just care that it's positive. At 10, this number becomes big and negative. So negative. Thus, the original function, and I'm going to change the color again to orange one more time. Original function is smiling, where the second derivative is positive, and grumpy, where the second derivative is negative. If the point changed, actually, let's not do that. That's usually how vertical asymptote is identified. If the point changed the concavity, this is called point of inflection because it inflected the graph. Graph was like looking like this, and then inflection happened. Here's example of an inflection point. So kind of makes sense. Or with the asymptote, it was a cup on the left, and cup would collect water. That's what concave up means, concavity. And then down on the right, which means water would slide down. Sometimes I explain it like this. Concave up, concave down. Let's answer those questions now. Answer 3. Answer 3 asks about interval of concavity. And you can write down that the function, the original function, is concave up on minus infinity. Why did I include this? So weird. Don't include minus infinity. Minus infinity to 23/6. Concave down on 23/6 plus infinity, like so. Also, I see in my notes, if it's hard for you to know which test points to use, you can also figure out the point, approximately 3.83. And now you know that 10 is good enough choose? Because sometimes you will have a point like 3/7 pi. What is that? Well, either you figure out a little bit what this point is, or you can approximate it. Then you can use past points after this. And finally, answer number 4, what is the inflection point? Well, the same problem is, are they asking for a point, or are they asking for the x value of the point? So usually they ask you for inflection point or point of inflection. Inflection point. Point of inflection is 23/6, comma, and then you plug it to the original f at 23/6. But if not, they just ask you for 23/6. Then you're lucky. Then nothing else to do here. So if you want to know the answer for the output of this point, every time the very last step, you plug into the original function. That's kind of the point here. So it's going to be 9 minus 2 times 23/6 e to the 3 times 23/6. These are my 4 answers. Intervals increasing, decreasing, CP first, then integrals intervals for function is increasing, decreasing, then concave up, concave down, and points of inflection. Good. This one I did not mess up. I'm very happy about that. So that's what you should know. Practice number 12. Let me show you. So, highly recommend to do that. This one. Practice that one. Those are like very classical problems. This point will have 2 critical points. Oh, this point will have 2 inflection points. So you will have concave up, concave down, concave up. In general, the higher the power are, the more times the function will be changing the direction. So up, down, like so, for example. And that's why it's interesting to have polynomials with higher powers. So practice that. Let me write it down here. Practice this problem, this e to the stuff, and practice number 12. Both are very good. No comments. Next one in my list is number 3, number 2, 11, 12, 3. Okay. 17. Let me see what's 17. I made a list basically of what I want to show. Practice at least one with the ratio. Figure out how you do quotient rule, like number 13. But in general, this is good. And if you can do these, you're amazing. So it's good. Oh, the fencing problems. Yeah, let me check also something very quickly. But the fencing, oh, I guess you can write down the fencing problem. Here it is, or just copy paste it. But you need to be good at those optimization problems, you know. But the thing is that I put the very classic one. I hope you'll be fine because I put like very, very common problems, which I like the most. I like fans. So I like using fans for the problem. Should I like snip it? I guess should. Snip. Here you go. Let it cut off. Let's see if I missed something important. No, should be fine. Let's do that. Famous fencing problems. I'm saying it because while you are suffering with those fencing problems, all students in America are doing the same thing. Students in Harvard, California, colleges in Ohio, they all have the same problem with those fencing problems. It's basically a classical book. So they just put it in the book and everyone have to go. It's an American book. That's why I actually never seen those problems before I start teaching. There are 2 types of fencing problems. Let me write it down. Well, let me write down it's like optimization problem, right? We know that. Optimization. Optimization problems. There are two types of problems in optimization we gave you. Problem type number one, optimize volume, area. In this case, it is area actually, whatever, right? You got it. Or minimize the price, minimize the cost. So if you see dollar sign or mentioning dollar, guess what? That's the second type. They more or less the same, but it's just lots of reading and thinking. If you do lots of them, if you solve lots of them, you get used to them. So let's start it. You see the fence, you feel good. When you see the fence, that means I told you to practice it, you practice it, and now it's a test. So that's kind of, I see that it's a good sign. And you, step one, you read it. Step two, you draw a picture right away. The moment I see the shape mentioned, I draw the picture. That's one. Picture. I see the fence is built a rectangular. Okay, yeah, I know how rectangle looks like. So if it says spherical, I draw a sphere. Circle, I draw a circle, blah, blah, blah. Triangle, triangle. So I know rectangle. Then you write down what is given. That's classic. If you take physics classes, that's literally the same thing there. I see that area is 320. Area is 320. Well, very nice. I like that. Materials, dollars are involved. So now you know they should have, it should involve some kind of cost function in it. And it has different dollars. $14 something something, $3 something something. And now they ask you, and then read the question. The last part is the question. Find the width. Well, I will find both. Width, length, and area. That's what I'm gonna do. Find width, length, area is right there. Width and length. Oh, in total cost, right? Total cost. That's what I will do together with you right now. Well, if you don't know something, which in this case, you don't know how long the sides are, call them X and Y, okay? X and Y. And you can call them X and Y, and then at the end, you can choose which one is L and which one is W. If you notice in your homework, you did everything correctly, but it did not accept your answer. Do you know why? Because math showed you that W end up to be, say, 700, and L end up to be 15, and you wrote it down like this, but that's not correct. Width should be smaller than length. So even though you named it W and L, math fixed it. Math said, no, this is length and this is width. So you're supposed to be a smart scientist who understands that. So math did right, and you're supposed to now fix your own mistake that you did not guess which one is X and which one is Y, which one is W and which one is L. That's why not just call them X and Y and then decide later? The longest side will be length. So let's call it X and Y. In my case, X, yeah, whatever, it's fine. Step 3. Step 3, write down equation. As many as you can, you know. If you have many equations to write down, write them all. In this case, I know area. Area is X times Y, or in this case, length times width, right? Okay, I already feel good. It feels even better to know that I know some formulas. So that's supposed to help you on test anxiety also. And then I noticed that actually this product is given is 320 feet squared. Okay, that will be a restriction function. Restriction function. Because X cannot be infinity, and even X cannot be a million. If X is a million, Y will be 0.00000 whatever. So this number restricts us to have some entrance. 320 total area. Let's write down. Area is 320. So that gives restrictions to X and Y. And we can find X and Y from here. X or N, Y. Step 4, you write down the objective function, OF, objective function. That's the function you want to optimize. Optimize. That's why they call it objective function. What is the object of our work, basically? What's the objective? Oh, that's the English word. What's the objective here? Cost. They want me to minimize the cost function. I remember this because it says find the width, blah, 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 to make sure that we have most economical construction for decimal place. Don't care about that. But most economical construction. Oh, they want to minimize the cost. Minimize the cost. And again, since I'm taking examples from your homework for the exam, you will never get anything unusual, not like maximize the cost suddenly or whatever. So I guess that's what health industry is doing. They doing the position problem, how to maximize the cost for people who buy medicine, which is very sad actually and not funny at all. So let's build a cost function. Cost function will be how much the whole total thing costs. Well, what is the whole total thing? The total thing is dollars per foot for what? For the site. Oh, so we're spending money to build the sites. Here they are, fence, 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 fence. That is perimeter. So we know how to figure out perimeter. Perimeter is add all the sides together. So it's going to be x plus y plus y if I just write down it as a perimeter. And then you multiply each side by how much it costs you to build it. So perimeter will be just that, right? But then when you multiply it by dollars times dollars or whatever money is, then it becomes cost function. And I just need to read carefully which one is which. So I know x is width. At least I chose it randomly, actually. It's like a random guess. Why not? I could put y to be width. So let me see how much width costs. Oh, it says 3 sides will be $3. And the fourth side is 14. So it doesn't even tell me which side is which. Sometimes problems tell you, oh, there's a river over here. So the long side should be more expensive because it's wrong. It has rocks. Blah, blah, blah. No, in this case, it's just very random. So any 3 sides, multiply them by 3. And the fourth side is more expensive for some reason. So it's going to be 14. Well, I can do that. So I'm going to be times 3 times 3 times 3 times 14. Does it make sense? So like very random guess, to be honest. And of course, you could add up those together. I'm not saying you could not. Just that's how I would explain. 4 sides, 4 different dollars, but 3 of them end up to be the same. Now you can write it down like as a smart individual, which is 6x plus 3 plus 14, 17y. Yay, put it in the box. This is what we're going to be maximizing or minimizing. In this case, minimizing. Questions about
I have a question. I'm sorry, just to make sure. So it doesn't really matter which side you put the more expensive side on. So like it could be on the X or the Y. It doesn't matter. You just got to make sure you have 3 and 1.
Unless they say something. So in this case, it says that's English for you. So that's the thing. That's what I don't like the most, right? That you have to read carefully in the math. They have, which like super freaking out about integration, antiderivatives. You need to read English. The fence along 3 sides, $3 per foot, and the fourth side, $14. And it's like literally no information which one is which. So you choose randomly. And it means they don't care. But in some problems, they say the west side should be more expensive. Then you have to remember what west is, which is also like, why do they assume that when I'm freaking out, I remember what the west is? So, you know. And sometimes they say there's a river on the third side to the east, whatever. So in this case, I like it that they don't care. And actually, math will fix it itself. It will figure out which should be the most expensive. And guess, technically speaking, as a practical individual, we can guess that the most expensive site will be the short one. Why would we save money by making long sites to be expensive? So if there's no restrictions on the choice of sites, X probably will be the short one. And it will be $14 per foot. Oh, that's very nice what I just said. Yeah, thank you, Pastor.
But I get it. Thank you. Yeah, I get what you mean. Thank you.
No, good question. So I like to write down this step number 5 is to kind of like make a system. We have objective function and we have constraints, what I call restrictions. In American books, they also call it constraints. So again, new English terminology shows up in this chapter. C is 6x plus 17y, while let's do on the left-hand side, why not? 320 is x times y, and it's a system. It means it is happening at the same time. And we want to minimize this first function, but we don't know yet really well how to work with several variables. Well, actually, in implicit differentiation, we kind of did. Anyway, you use restriction to solve for one of the variables. That's your step 5. Let's call it equation 1 and equation 2. From equation 2, a random choice. Just choose whatever you like. Let's do x. Doesn't matter, to be honest. The answer should be the same. 320 over y. Okay, put it in the box. That will be important. Plug it into 1. C equals 6 times 320 over y plus 17y. Nice. Now it has one variable. I know how to maximize or minimize it. Do you know how? Take derivative. Like I mentioned at the beginning of the review, the moment you see the word minimize, maximize, find minimum, maximum, global, local, doesn't matter. You know the next step. Step 6, you find derivative, set it equal to 0 or D and E. For optimization problems, you don't use D and E points. Actually, you can use them. You're supposed to use them, but they usually not in the domain. We do not even identify domain right now because it is exam, so I don't really expect you to waste time on that. But as you understand, x should be bigger than 0, y should be bigger than 0. But also there's a restriction over here. Y cannot be infinity and x cannot be infinity, so not 1,000,000 either, blah, blah, blah. So there's a restriction on how far they can grow. Blah, blah, blah. That would be nice to do it on the exam, no, on the quiz or some kind of written for work. On the exam, I totally understand it. You will be fast. You need to be fast. Static, so derivative equals. Let me make it fast, and then I will ask you if you understand it. 6 times 320, in my notes, it says 91920. Oh yeah, looks correct. Divided by y squared plus 17. So now it's like a question, did you get how I do that? If not, the trick is to rewrite nicely. 6 times 320 over y is 1920 over y is 1 times 20 y to the minus 1. And now you know how to differentiate. Minus 1 goes down, raised to the minus 2. And then in this case, I highly recommend to rewrite it as a fraction because the next step will help you if you have common denominator ready. The next step is good to merge everything into one fraction. I will let you know why right now. Y squared in the denominator minus 1920 in the numerator plus 17 y squared. This is where you should check zeros and D and E's. Well, zeros come from the numerator, so you only need to solve the numerator. D and E's, they come from the denominator. From the denominator, y equals to 0 is the solution, but y cannot be 0, so we ignore it. Let me write it down. Step 7, find critical point, CP. Y squared equals to 0. Critical point is called critical, so denominator gives you critical points too. Y equals to 0 is not. Oh, it's gonna shut down. I can see it already. Little tablet is like overheating. It's not in a domain, not in the domain. So we're not gonna include it. It's not. But 1 minus 1920 plus 17y squared gives us some kind of point. Y gives you plus or minus a square root of 1920 over 17, which is, if you're curious, plus or minus 10.6274. I like exact answers, so I always prefer exact answers. And then you check, we have 2 critical points, check. No, we're not supposed to include negative, duh, because we're working with objects. Side's not supposed to be negative. So 1920 over 17 in this case is the only one that should be included. It's basically like a global mean max on the closed interval because we are working on a closed interval. Because X and Y has restrictions, P, right? So here's my critical point, and guess what? That's gonna be the answer. The thing is, you're supposed to check it. Of course, you're supposed to make a sine line, put it on a sine line, da da da. And since we expect it to be minimized, right? We know how it should look like. On the left, the derivative, which is y prime, right? Should be negative, negative. On the right, negative, I said negative. On the right, it should be positive. The original function y, which is not y, original function is c, and this is c prime. Yeah, original function is decreasing, increasing. So if cost is decreasing and then cost is increasing, then guess what? This is minimum. You're not going to be doing this for the test. Nobody will be checking your work. Your job is to answer the question. And guess what? If you have only one critical point and you know there is a minimum price, this problem is supposed to have the answer. Why would it not have the answer? There is minimum price. So that's the answer. So kind of a cheat sheet to let you know that is the answer. For the quiz and for the written exams, we usually take points off if this was not happening. So we're going to have exam 3 in my in-person class. And we will require this work. But in online exam, that's one of the few good things about online exam, that we don't check your work. It's kind of good and bad at the same time. 9. You now know that y equals the square root of 970. I like to have exact answer. Over 70 is your optimal y coordinate for the fans. And now I'm gonna go back and see if it's width or length. Oh, actually, we don't know. Just because I put it as a length does not actually tell me anything. Only the side of it will tell me. So from here, x will be, I remember that x was 320 over y. I even told you to put it in the box. Oh, I put it in the, here. It's in the box over here. So I can find now the next coordinate or the next answer, which is, you can even write down a weird way like this if you want. 320 times the square root, but now it's going to be 17 over 120. You don't have to, but here it is. And now I don't know which one is which one is length, and I have to actually figure out the approximation of it. So one is 10.6274, and another one is 30. Well, yeah, if it's 30, we know that x ends up to be length. And then y ends up to be width. So my guess was not correct. See, I put x to be width, and it's not correct. And that's why I know now how to answer. I'm not gonna call x and y width and length. I'm just gonna answer in terms of width and length, as you will do it in the research group. People will ask you, so what's the width and what's the length? They're not gonna ask you what x and y is. And you will say answer width w equals 117. Length L equals 320 times this is 17 over 1920. And then I also ask you, what if they ask you, so what is the cost? We need to know as a company how much it will cost us. Good job for minimizing the cost by figuring out the size of each fence, length of each fence. So the cost will come from the formula we created. And the formula was 3x plus 3y plus 3x plus 14y. And then we simplify it to be 6x plus 17y. And you plug it in 6 times. Well, now I don't know what. Oh, here it is. X is still in front of me, actually. 6x is 320 times 17 over 1920 plus, yeah, plus 17 times y, and y was the original square root. So that is the answer. And then you approximate what it is to give people some kind of number sense. How many square feet is that? I don't have it in front of me, unfortunately. Yeah, what do you think about that? No, nice. Very cool.
Yeah, that was good. I was following along, got the same answer. Good.
Thank you. Oh, that's very good. Yeah. So as I always say, people ask sometimes, let me 1 to 23. People ask sometimes, but I studied and I did not do well. And I always recommend, did you actually close everything? Did you actually do the problem by yourself? Unfortunately, just watching my videos or any videos is not enough. You need to pause. So my recommendation always is the same. You pause, and then before I solve it, you solve it, just like you just mentioned. And then you stuck, which is fine. And then you play and you see the solution. But then you go back and you do it by yourself with closed notes, no formulas. Only if you can do it by yourself. That's when you know you're ready for the test. If you always keep watching other people doing it, it's kind of like watching someone doing push-ups. You can watch it the whole day and you're not going to get abs from that. You need to actually start doing your own push-ups. That's my favorite. Next glitch. That is number 23. Let's jump into antiderivatives because you will have several problems there on antiderivatives. Then we're going to go to approximations after that. Here we go. So antiderivatives, we only give you kind of like one formula, but we expect you to know tricks really well. So let me review that. Let me change it down. The end of chapter 4, I think. Antiderivatives. Antiderivatives are antiderivatives. Okay. Antiderivatives are integrals. It's a very American thing not to mention this for like 2 chapters. It's like a secret. Oh, let's call it antiderivatives. We're undoing derivatives. Well, that's an integral. We're literally mentioning like in 2 chapters. I don't know why they keep it as a secret. So, which means we gave you a formula. When we were taking derivative of x to the n will go down, multiplied basically, by the x, come on, x, of course it's, yes, x to the n minus 1. But now we undoing it. So they called, that was original thing, right? So that was derivative. Now we're going to have a formula, x to the n plus 1 over n plus 1. That's how you undo. So that's why it's called antiderivative, which is an integral. And what they do, they call original function small f. No, small f is derivative. And in capital F, it's antiderivative. Original or antiderivative. Basically, what gave you this result when you differentiated? Don't overthink this too much. It's exactly how I just said it. What was the original function that you differentiated and it gave you 3 cosine minus 9 sine? That's what they're asking here. So let's work on that. But before jumping into this problem, it's 4.7 I just found. Before jumping into this problem, we need to make sure, so this is new. We need to make sure you remember your tricks. Know your tricks. Sine prime, let's not put it here. Sine x prime is cosine. Cosine x prime is minus sine. You need to know 4 for now. Tangent goes after that. Tangent really likes secant. So when you differentiate tangent, it gives you secant squared. But secant really likes itself. So secant copies itself first. And then, fine, it takes tangent because they're friends. So that's the idea. Now, if you see secant squared in front of you and they're asking you to find entire derivative, you're just asking the question, what function gave you secant squared? And you know it's tangent. So let's do it. Here's the problem. 3 cosine minus 9 sine. You know it's derivative. So they ask you to find the original. Here it is. Solution. solution. Original function will be what gave me 3 cosine. Maybe write down the formulas on the test. You cannot have a cheat sheet, right? But when you start a test, you can write down whatever you want. Maybe write those down in front of you, and then you don't have to remember. This formula and the power formula, it's power rule. Undoing the power rule. So, what gave me 3 cosine? 3 sine gave me 3 cosine. And also you can always check. You can actually differentiate it. We're going to do it later. What gave me -9 sine, -9 cosine? And then you actually check, wait, but derivative of cosine is minus sine. So minus gives you plus. Wrong. Should be plus. What gave me minus sine? Cosine. And then times 9. And then the new thing shows up is this c plus c. That is because derivative of c is 0. So this thing has 0, but it means maybe the original one had like -100, plus pi, plus 73 pi, and so on. C is a constant. That means the answer is called a general solution. General solution. And that means the answer is also called family of solutions. It's a family. Because we are family of solutions. So, any number there will still give you correct answer. If they just want you to find general solution and you see in Weber plus C, then this is the answer. Good to go. You write it down. You're happy. If that's not the case, then you have to keep going. Well, how do you know you have to keep going? Because of this, they tell you, oh, and also f of 0 is -2. The moment you see this little note, they want you to find C. Step 1, we found f. Step 2, find C. Find C using initial condition. IC is conditional condition, or it's also called IV, initial value. And in general, those problems called initial value problems. Initial value says, initially at 0, I had -2. So if you want to see some kind of applications, it's like a temperature. How the temperature, so temperature, see sine and cosine is escalating up and down, up and down. So, but originally, when I started checking the temperature, it was -2 Fahrenheit. So knowing this initial value, now I can give you the original function of the temperature. Not the original function after taking derivative. Derivative answers the question, how fast the temperature is changing. 3 cosine minus 9 sine fast. But the temperature function is 3 sine plus 9 cosine. And they say, but what is your C? Well, we're going to find from f at 0 equals -2. To do that, you plug x equals to 0 into f. That's going to be 3 sine at 0 plus 9 cosine at 0. And then you remember the right-hand side. The right-hand side should be -2. So, oh, that's how we're going to find it. Because there's a C at the end. Plus C, well, now the colors match, equals to -2. Let's not put it in the same color, because I'm afraid you will think that it matches -2 all the time. That's not necessary to keep. And now you solve it. Sine of 0 is 0. Don't care about that. Cosine of 0 is not 0, so it's 9. 9 plus C equals -2. C equals -2 to -9. 9 minus 11. -11. Here you go. Answer. F equals, let me see, a little bit, 3 sine x plus 9 cosine x minus 11. And you type it in. There should be no C anymore. That's called particular solution. Particular solution. From the whole family, we took out one particular solution using initial value. Note, you can check your answer if you have time. Note, you can actually differentiate f and see if it matches the original thing they gave you. It can be 3 cosine x minus 9 sine plus 0. Wait a second, that's literally what they gave you. Matches. So these problems are good because you can check that it matches the original. And also to explain what happened, we had a family of functions, since there's lots of sine and cosine waves, and they all shifted up and down by c. It's a vertical shift. Remember from pre-calculus? If c is positive, it's shifted up. If c is negative, shifted down. So it depends on c. But the thing is, when they gave us initial value, they pointed at some kind of specific answer. They said, well, at 0, it was -2. And that's how we could find or choose the specific function from the family of solutions. Initial condition helps to choose a function from the family of functions. Oh, I actually have a beautiful picture. I just saw it. It's over here. So that's how you do it. What do you think about these questions? Let me show you the picture. Can you do that initial value? And now let's do it twice. Here it is. Check it out. See how beautiful. Here it is. Oh, I told you there were weights. Those graphs from open. And then they gave, and it took out a specific solution from the family solution. It doesn't like too heavy. Good. Let me check the chat. Yeah, nice. Next one, that was 23. 27. Let's do it twice. 27 is this one. It talks about acceleration velocity. I love those problems, which probably tells you what I mean. I love those problems. I always put them on test for calculus 1, calculus 2, and calculus 3 exams. We're going to have them all the time because we're going to have them in more dimensions in calculus 3. Let's do it. And we're going to do differentiation and integration in upper dimensions. So that's going to be very fun. And students are very good at those problems. Most of the students are very good at those problems. And that's why I like it the most, actually. I like the problems that students are good at. Then I can put them on a test and I feel good about it. So that is number 27. Your job is to know the terminology, acceleration, velocity, and distance, or disposition or position, and to know their relationship. So from position, you differentiate it, you get velocity. You differentiate it, you get acceleration. Thus, guess what? If you find antiderivative, you go back, right? So that makes sense. Antiderivative means you keep going back. Antiderivative one more time. The problem is we don't want to have C every time. And that's why they gave us 2 initial conditions now. One for S and one for V. We're going to use both. Solution. I didn't even read the question, you see, because they're very standard. Question, I just need to know what they gave me, A or V. Because from that, it depends how many antiderivatives I need to find. Oh, they gave me A. And then what are they asking for? They're asking for position, S. Well, that means we need to find antiderivative twice. Okay, if A is given as 36t plus 10, then V will be antiderivative of A. You ask yourself, what gave 36t when you differentiate it? Well, 36t squared over 2 gave me that. Wow, you're just like, how did you do it? That's weird. No, it's a power rule. So you have c n plus 1 over n plus 1, right? So it was 1 plus 1. Maybe I'll let me write down once. 1 plus 1 over 1 plus 1. Now, you ask yourself, what gave you 10 when it was differentiated? Oh, 10t. So again, you can always check yourself, actually. V is 36t squared over 2. You can simplify that. 18 plus 10t. If I differentiate that, then it will give me 36t plus 10 matches. However, it has annoying c at the end. You can call it C1 if you want, or just C, because we're going to have another one. Some people do A, B, C. Countries do not agree actually what to use, but most people use C because C is constant. That was step 1. Step 2, find C1 using initial condition. So let me put this in the box because this is important. We found V. That would be the nice answer unless they told us to continue. And they did tell us to continue. Find initial condition for V. V at 0 must be 9. And the process is the same as before. Plug 0, made it equal to 9. 18 times 0 squared plus 10 times 0 plus C1 equals to 9. This is a lucky case when C is just 0. No, when C is just that number 9. So it's not always the case. Be careful with that. Don't always assume. But because everything else is 0, C1 equals to 9. Now you can, if they ask you to find the first one first, then you answer 1. The first one first. I mean velocity first. Velocity is 18t squared plus 10t plus C1 plus 9. That's the answer number 1. Continue. Step 3, we repeat exactly the same process, but with V. S is antiderivative of V. It's going to be 18t cubed over 3. 2 plus 1 over 2 plus 1. You don't even have to calculate it twice. You calculate it once and divide by that number. Plus 10t squared over 2 plus 9 times t plus c2. That is important. Put it in a box. You can simplify if you can, or if you want to. 18 over 3 is 6. Find step 4, the last step actually. Find C2 using initial condition. And now I need to go back and find the initial condition. It is S at 0 must be 8. S at 0 must be 8. Plug in 0, and I will speed it up. So 0 plus 0 plus 0 plus C2 equals to 8. Nice. We are lucky in these cases because we don't have cosine. Cosine at 0 is not 0. And we don't have exponential function. E at 0 is also not 0. And in those cases, you have to be careful. In this case, everything becomes 0 except C and 8. So that's the answer. Final answer, answer 2, and the final answer is, what is S? S is position, right? Position is, or distance, 6t cubed plus 5, I'm simplifying, t squared plus overheating, plus 9t plus 8. That is the final answer. And I will do the final answer. Question number 5. Find S at, like S after 1, what is minutes or seconds? Particle was moving, velocity time, t time. Oh, it doesn't even give you any unit. Okay, whatever. After t equals to 1. That's like an extra question. Extra question. In case they will ask you, make sure you know what to do. That means they want you to plug 1 into your answer. 6 plus 5 plus 9 plus 8, which is 11, 20, 28. Wow, finally I woke up. 28. That's like extra question if you need to do it. So let me put it in the, there's an extra question. You don't have to do it. And that's going to be answer 3. What do you think about this? A little bit. That was antiderivative twice. And also you need to know what to do with this wording. Even though it's the only applied problem I actually like a lot. Because I recognize words acceleration, velocity, position, path. And now I know what they give me. It's always the same. Oh, they said 6. It's actually not extra question. I totally did not see it. Did anyone notice? They actually did ask that. It says 6, not 1. Okay, that's not an extra question. It's literally a question. A3, erase extra question. It is 6. well, then it's like lots of calculation. That kind of another one. Oh, but I have it in my notes. Yay. 6 equals 6 times 6 cubed plus 5 times 6 squared plus 9 times 6 plus 8 equals, my notes say it is 1538. Again, I don't know if it's correct or not. That's what my notes say. Very nice. Let's go to the annoying problems. My least favorite ones are, oh, before we move on again, before we move on to the areas and approximations with areas. Those are my favorite ones. They're very time consuming and not very smart. So I don't know why they like it so much in that book. But I also wanted to do one more example. Can you find if small f is given as 17 over 3 secant squared x minus a cube root of x to the 5 plus pi. Find capital F at 0. Can you do that? So let me do it with you. Just like random integration happening here. Just created something on the floor. Solution. Capital F is called antiderivative. Antiderivative. That's the integral, basically. We're going to do it literally after this exam. So F will be, what gave me 17 over 3 secant squared? This is when I'm afraid you can freak out, but maybe it will help if you write down the formulas right when the exam starts, because you cannot have a cheat sheet with you, but you know what? Your brain is a cheat sheet. Maybe that's what I did when I was a student. I had very bad memory, so the moment I got my script, the exam starts, I just write down everything I don't want to memorize. And then I stare at this when I have in trig functions or anything. Secant squared comes from differentiation of tangent. Oh, so 17 over 3 secant squared came from 17 over 3 tangent x. And you can always check, differentiate 17 over 3 tangent. It gives you secant squared. Minus, and I have no idea what to do with this weird x. Well, maybe I should write it down as x to the 5 over 3. See my lecture 0, I think I attached it to the modules when I practice powers. In general, this is how I memorized it. X to the, and let's see, m root n is x to the, whatever is higher will be higher in the fraction. And whatever is lower will be lower in the fraction. That's how I memorized it. And it goes both ways. It's very nice visual memorization here. So, of course, 5 and 3, my handwriting were on the same height. But I can imagine in my mind that root is lower. It's a root of the 3, if you think about it. So 5 should go on the top because it was on top, like so. And that's how I don't mess up. Those are roots. So also it was negative, don't forget. So it's negative x 5/3 plus 1 over 5/3 plus 1. And the beauty of it, you only need to calculate it once, and then you just copy the answer to the denominator. And there's also pi. What gave me pi after differentiation? Pi x. That's what gave me pi after differentiation. Let's see. Let's rewrite it. Nice. 17 over 3 tangent x minus x to the, how to do fraction, let me quickly remind you. 5 over 3 plus 3 over 3 gives you 8 over 3. That's how I do. 1 can be 3 over 3, 5 over 3, 8 over 3, 10 over, no, 5 over 5, 8 over 8, 10 over 10, 100 over 100. You can always merge them as two fractions. So 8/3 divided by 8/3, you just copy. I usually multiply by reciprocal right away. That's pi x plus c. And also it will be very hard to type this. You will have to parentheses carefully. So I would again rewrite and type it in as minus 8/3 no, minus 3a. 3a. You multiply by the reciprocal, which means you flip it. It's a fancy way to say you flip the fraction. Plus by x plus c. Then this is the answer. But then they ask you to plug 0. Oh, can you plug 0? Yes, you can. You will have f at 0. Tangent of 0 is 0. X, whatever that is still 0. Pi x is still 0 plus c. The answer is c. Whatever. I just made up like a weird problem. But my point is, also don't forget that tangent at 0 is 0. If you don't remember that, remember that tangent is sine over cosine, and sine is 0 in the numerator. That's why tangent is 0. Cosine is not 0, so it gives you 0. 0 gives you 0. It's like genius phrase to say, and that's why 0 gives you 0. Okay, that's good. Not too bad. Let's go to next problem. What problem is this? This was 27. I want to do or 31. I don't. Yeah, post the questions in the chat while I'm looking. So we did, yeah, both of these. Let's do both of these. Like you, look at this. I don't know. It's just, it's time consuming and they still want people to do it on the test. At least you guys have 2 hours, but we put this on the 50 minutes exam too. And it's just, I always feel sad how many students just cannot be fast, and that's okay, but then they don't do well on the test. American exams are very fast. They just, it's a race, which is very not good for the STEM people. Science is not a race, you know, it's supposed to be a thinking process. So it's nice to have several hours when you can actually peacefully think about what is happening. And they want you to read English fast, like, yeah, amazing idea. Estimate the area under the graph from 0 to 1 using 5 approximating rectangles, right? And yeah, they give you lots of information basically, right? Endpoints and then 2 decimal places. Who cares about that? But unfortunately, web work does. I just realized. So here you go. Let me give you a small review of. Oh, that's not the same 30 I have in my notes. That's interesting. I have a different problem. I don't want to do tangent. It will be too time consuming. Oh, interesting. My review has different problems here. Maybe I looked wrong. My review has a different function. It looks much better than tangent x squared. Not a big difference, but
you have 144 minus x squared. Is that how yours is?
Which is much better. Like, why would we bother with tangent? I guess you don't have to simplify tangent for web work, but I don't want to use that one. Let's rewrite it into what I have in my notes. I wonder, did they change it recently? I have no idea. They don't really let us know. It just suddenly changes. 144 minus x squared, 0 to 2, using 5 approximate rectangles, right, and points to decimals. Okay, everything else is the same. I wonder why they changed. Maybe I should make a YouTube video then, and that's tangent. Yeah. So I would write, you know, as a person who doesn't speak English as a first language in STEM, this is what I do. I write down stuff without English to know what they want from me. I see f, I will write down it's y. Why not? Y equals 144 minus x squared. Got it. Then I see that x is from 0 to 2. Got it. 5 approximating rectangles. 5 rectangles. Got it. Right endpoints. Right endpoints. All of these are mathematical facts I need to know. Everything else, not really. 2 decimal places. Yeah, that's for the end. So before even figuring out how to start, I want to find the step size called delta x. Step 1, find the step size. Because we cannot proceed without a step size. Step size is that delta x thing you've seen. And it has a formula end minus beginning divided by the number of intervals. By the number of rectangles. Well, that's the same thing actually. Interval in this case, number of rectangles. So I'll put in the box. This is a formula. Remember this. This is how I start. B minus A over N equals 2 minus 0. N is 5. Actually, I'll write down N 5 rectangles. If they want me to use 5 rectangles, then the picture will be X and Y, and there's some kind of function. In this case, it's actually parabola, so I can draw it nicely, but you don't have to. You just need to know that there's a function and it creates a shadow, this kind of shadow below. Or imagine it's a roof and now it covers the parking lot. They ask you to figure out the area of this parking lot. Well, a vertical, I guess, area. I don't know. You figure out the idea. A window. Oh, you can see there's a window. Here's the window, and I want to know how wide the window is. That's what they're asking here. Approximate the area under the graph. So not only I know it is from, okay, so this thing is too much. I don't need all of this. From 0 to 2, that's what I need. That's important. They can change, they can choose any interval they want. I only want this part of the window. How big this part of the window is. That's one thing. But also they say use 5 rectangles. That means it will be 1, 2, 3, 4. That did not look good. It should be 5 intervals. To create 5 intervals, I need to have 4 cuts. First integral, second interval, third, fourth, and fifth. Here is my 1, 2, 3, 4, 5 intervals. But what is the width of each interval of the rectangle? So to find that, that's your delta x. That's your delta x step size. That's 2/5. 2/5 or 0.4, whatever is easier for you to imagine. So each is 0.4. Oh, okay, I got it. 0 is A, 2 is B. And now it's important to know which formula to use. We have 2 formulas. We have left rectangle, left endpoints rectangle, and right endpoints rectangle. I think I posted some nice animation about that in announcements, but if not, I can post. Left one, the formula is starts the same. It's delta x. So make sure you multiply by delta x. And then left one starts with the left endpoint. So x sub 0, blah, 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 blah. And it doesn't go to x to the sub n. It stops one way before it. Because we only need to use all the left ones. The very last one is the right endpoint, so we don't use. With the right endpoint, we skip the first one, and we start with the fx of 1. Go, 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 go. And then we do fx minus and 1 and minus 1 plus f of x and n. And like so. So you need to know, to be honest, on the exam, they ask you all of this. And I think they also ask you the midpoint, which is even worse. The midpoint requires more calculation. It's not really a big difference, but it's just requires more calculations because it's still delta x. And you include all of them. But now you don't include x0, blah, blah, blah. You include middles. Let me zoom in, which is very convenient that I can do that. You find these middles for the midpoint. There'll be 1, 2, 3, 4, 5 midpoint. And then you will have f at x. Let's do it dash 0. Well, let's do it 0. Why not? Fine. Plus f of x 1 dash and so on. F of x n dash where, and I'll write down where x dash, and professionally it says we usually do I, that's a counter, but you don't have to write down. I just want to explain what it is. Midpoints. Midpoints. Do you know what midpoints means? Middle point. That's English as well. So you need to know all of these 3. I have videos on all of these 3, so let me just do one, and then you will feel good because you can always rewatch the other. So the most important left endpoint start with the left point, right endpoint skip, and go to the right point. Thus, since they told me to use right endpoints, let me show you how to draw it. Well, you don't have to know how to draw it for the exam. Right endpoint means I'm going with I'm skipping the first point and I'm starting with my second, which is first right point, if you think about it. I shoot it up, and the moment I hit, let me change the color. And the moment I hit the function, that's my f at, right? Height is f at. I shoot it, move to the left, down. That's my first rectangle. Repeat, right endpoint, shoot, touch with the right corner and go down. Go to the left and then down. Up, touch with the right endpoint. Up, touch with the right, up, touch with the right. And then you count. You better have 5 of them because they told us 5. If you have extra not enough, you messed up. Or I messed up. So 1, 2, 3, 4, 5. Yay. And basically the idea is that this area in yellow approximates the exact area. And the more rectangles you have, the less little gaps in over there you will have. See? Is it underestimation or overestimation? It is underestimation. How do I know? From the graph. The function is concave down, and it has, the approximation has empty gaps below the function. Those empty gaps means that the answer will be smaller than the actual area. That's a very clever idea to estimate things. Engineers use it a lot. And also mathematically, it's very nice. Okay, all this blah, blah, blah. Let's actually do the stuff. The stuff is done over here. I'm going to draw the interval. I'm a visual learner, so I like to draw things. And I know that it starts with A, and A is 0. And it ends with 2, and 2, no, it ends with B, and B is 2, like so. Now I have 5 intervals. It says it's 5 rectangles have 5 bases. 5 bases have 5 intervals. And each size or step size is 0.4. So I'm gonna do 0.4, 0.8, or 2/5, and add 2/5, 2/5, 4/5, and so on. 0. I have 2 more. Plus 0.4, 1.2, 1.6, and then you check yourself. 1.6 plus 0.4 indeed is 2. So very nice. This is how they look. Very nice. Step size everywhere is delta x, delta x. It should be the same delta x. That's the whole point of this idea, that the width must be the same. It simplifies the calculation. Anyway, the answer follows from here. So let me give you steps. Step 1, figure out the step size. That's the most important. When you know the step size, you're actually ready to go. I guess I recommend to do this. It's not required, but I recommend to find 0.4, 0.8, 1.2, 1.6. If not, you can do it right in the formula right away. Step 3, choose which formula they want you to use or which one you're required to use. Step 3, we're going to do right endpoints. So it's going to be R, and the notation is R sub 5 equals. And we know the formula. Delta x goes first. That's 2/5. Open your brackets, open it. And you skip the first one. So I'm going to take a highlighter, and I'm going to highlight to myself which one I'm going to use. I'm going to use 0.4, 0.8, 1.2, 1.6, and 2. Only the one on the right. So let me show you in red. Right endpoint, right endpoint, right endpoint, right endpoint. I cannot use the first one because it's the left one. And I cannot use the last one for the left one because it's the right one. That's kind of the idea. And now I know it's going to be f at 0.4. Whatever I highlighted, I'm going to write down. F at 0.8. So for me, visually, it looks very good. My brain knows how to proceed because it sees it visually. If you think you're a visual learner, then I highly recommend to do that. I like teaching visually because many of my students are visual learners. I definitely know that with experience. Right endpoints, and we only left with 2, f at 1.6 and f at 2. Close the bracket, grab your calculator, and you start calculating. And when you calculate, you don't keep it in calculator. You take a pencil and you actually write it down. 143.84, 143.36, and so on. Why do you need to write down in calculator? This one is a good one number. Because when they ask you for the left one, at least you can reuse them now, and you just add the one on the left and don't take 140. And if they ask you M, now you have to find Q fifths, and it's going to be F at what is between 0 and 0.4, 0.2 midpoint. We change the color. 0.2 plus F. What is between 0.4 and 0.8? 0.5. So usually you're not supposed to do it by guessing. Again, redraw it. Oh no, actually I don't redraw it. I go back for the midpoint. I go back and I calculate the halves for the midpoint, like so. Actually, you just need 1/2, and then you add the step size. Oh, I remember that right now. You just need the first one, that's 0.2, and then you keep the step size must be the same. So you add 0.4. That's 0.4. That's 0.6. 0.6 plus 0.4. That's 1. And it's exactly between 0.8, blah, blah, blah. So let me write this down. 0.2 plus step size, 0.4. And so on. That's middle point. And then you give the answer. What is that? What is that? What is that? Right one, I have the answer in front of me, 28448. What do you think about that? Isn't that boring? Those problems are my least favorite. It's just, they on the test gave you a problem with 15 points. I was so angry yesterday when I was looking at it. I was like, who thought it was a good idea to give students on the exam 15 points? So I changed. And now it has either 5 or 6. I don't remember. I got so pissed. Like, I'm gonna freak. I just need to know you know how to do it. I don't need you to sit with calculator for half an hour while you still have 8 problems or 12 problems to go. It's ridiculous. So I got kind of very frustrated. Yes. Let's do this one. Do you know that if you see a table in front of you, you should be happy with this thing? You only feel not happy if you never seen it before, but it is in your homework. I actually double checked. So why this table is amazing? Because it speeds up everything so well. It's exactly the same question we just did, but it already gives you the numbers. You know those numbers I was writing down, 143, 84, 143, 36, blah, blah, blah. Here they are. They are in the table. So it's a blessing from the skies that helps you to spend lots of time in calculation. So your job is to figure out how to work with this data. This is the data. So the data scientists do that. They stare at tables like this, usually in Excel files. So here's your data collection. And there's some problem, so there's some kind of application problem behind it, which I truly don't care during the exam. I can care when I have time for that. What I care is to figure out what to write down. Solution. This is what I'm gonna write down. I need to know A, I need to know B, and I need to know delta X from there. Delta X requires N first. So maybe let's not do that. N is a number of rectangles we're using, remember? Or number of subintervals. And then delta X follows B minus A over N. N is the number, that's number of subintervals. Okay, A and B is always very easy to know. If they gave you this problem, they say A is 0, B is 2. If they gave you the integral, which you saw, integral from 7 to 10, well, guess what? That's A and that's B. We can do this problem too if you. Well, in this case, A is input 0, B is input 60. Starts from 0, ends at 60. And apparently those are seconds. So 0 to 60, that's B, second. So 0 and 60. What is N? Well, I'm counting 1, 2, 3, 4, 5, 6, and you think it's 6, which is not true, actually. You need to count the interval Those 6 are points. Those are called data points. But interval is not a data point. Interval is you start from 0 and at 2. That's interval number 1. 24, 2, 3, 4, 5. Oh, it's 5. And also you always remember, if you want to remember, you can remember that number of intervals is always 1 less than number of points, because interval requires 2 points. Or you can jump basically from 0 to 12, 12, 24. Now I can find delta x 60 minus 0 divided by 5. My step size is 12. Step size is 12. And I can always check. It's true. Here it is. From 0 to 12 is 12. 12 to 24 is 12, and so on. So either you calculate using the formula, which I usually do, and then I check, or you see it in the table. Step 1, step 2. Step 3, you don't even need, remember step 3 was this line, and I would put stuff in it, and I would figure out the midpoints. This is given. Yay. So that's what makes your life easier, even. Happy face. So we're skipping the step. Step 4 is the result. Now they just need to tell you which to use, right endpoints or left endpoints. They say beginning. Okay, that's the beginning. Beginning means left endpoints. The beginning of the time intervals. So why did I do right endpoints in my notes? Oh, I just made a typo. I did left endpoints, but wrote it down as R. Well, that's lame. Yeah, in my notes there, I can see R. No, it's L. Because beginning. L sub 5. How do you know it's 5? Because 5 intervals. Then you can do R sub 5 if they ask you. And you can do mid 5 too, which is always the same idea. That's the one you will have to calculate. What is between 0 and 12? 6. And then you keep adding 6 plus 12, 18. 18 plus 12, 30. Wow, that took me like way longer than it should be to calculate this. Equals, continue, let's just do 1. Delta x, again, delta x is 12. So I know it's going to be everywhere. So the method always matters. It only matters what's inside of these brackets until we go to calculus 2. In calculus 2, we're going to have 2 more methods called Simpson's method and trapezoidal method. Because for you to know why we use rectangles, we could use trapezoids, for example, like this. And also we're going to use parabolas at some point. So then it will change the form. But in this case, 12, 12, 12 is the same. Left endpoint, I'm going to take a highlighter, and I'm going to highlight what I'm going to use. I'm going to use f at 0, which is 20, 12, which is 24, 22, 26, and I will leave alone the very last one. So I will not write down f at 0, f at 12. Why would I write it down if I have the answers? 12 plus 24 plus 22 plus 26 plus 24 equals 1392. Boom, this is the answer. If you want to write endpoints, you skip the first one, right? And you will have 24 plus 22 plus 26 plus 24 plus 21. Calculate. And finally, if you want to have midpoints, you're going to have 6. Oh, don't put 6. Oh, that's the one you actually cannot do in a table because you don't know the output here. It might not be necessarily a linear relationship and stuff. So we're not going to ask you to do this one then. If you have a table, that totally makes sense. What do you think about that? That's the approximation. Interestingly, that the point should be more or less, the answer should be more or less the same for L5 and R5. Because we're talking about exactly the same answer, just we're trying to approximate it from the left or from the right, and so on. Yeah, there's some question. Very good. Now, 20, then in my notes, there's 31. I think that's the one I did. 31, yes. And do you know that we do something like this with the integral? Let me find some kind of integral. If they gave you an integral and they asked you to approximate it using rectangles, and you do that exactly the same way. Yes, let me show you this. Example. Approximate the integral of 144 minus x squared dx from 0 to 2 using 5 rectangles. Using 5 rectangles and then write endpoints. Right endpoints. Right endpoints. Don't be scared from 0 to 2. Don't be scared. You see this, it's fine. You just concentrate, inhale, exhale, and then remember I told you, this is your interval. Start writing down things, you know, to come down. This is A, this is B. Solution. Step 1, Julia told you, always write down what you have first. A is 0, B is 2. Nice, we know that. What is N? N is 5. Okay, we know that. Amazing. Step 2. From there, you proceed delta x. 2 minus 0, 2/5. That's the same example I already gave you, so I just want to show you it differently. Step 3. Now, what's the difference? The difference is they don't give you, oh, what is the function like before? F y was 144 minus x squared. No, they gave you, don't be afraid. It's just hidden inside of the integral. You take a pencil and you like circle, fat circle. This is what y is. Y equals. So it just has an extra step. You see, you can write down a, b, n, and you can also write down y equals 144 minus x squared. It's part of the things given, just in form of the integral. And then you proceed exactly the way we did it before. So this is a genius connection between approximating areas below the graph and integrals. Apparently, this is how we can approximate integrals. Oh, maybe I should write this down. The question was approximate, APPR. Approximate integral. And let me put it in the nice red cloud. No, it's kind of weird. Let's do that. Here you go. And then you continue. Just same as same as number 3. I literally took the same example, but I will show it to you differently. Very good. Let's see if I wanted to show something else. I think I wanted to show you more logarithms. Just in case you struggle with logarithms. So think about any questions you have while looking for a nice logarithm function. Oh, and you know they call it Riemann sums, right? Should I like say that? They will say in these questions, I just saw that the terminology says also approximating rectangles, 5 approximate rectangles, right endpoints. But also they might say instead, or use Riemann sums. That's a math terminology. It's a very popular Riemann sums. And then it might be like R sub 5 and L sub 5. Nothing new. It's just naming it. So let's not put or. It's the same thing. If you see a phrase of Riemann sums in your homework, in the exam, it will be again in calculus 2 and calculus 3. They mean those approximations, because those approximations can be written in the form of the Riemann sum. Like delta x, this is what they mean, the Riemann sum. And actually, it's usually inside. I just like to factor it out. Delta x, and then f at n, x sub n, blah, blah, blah. So n goes for the left endpoint from 0. Let's call it I. I is a counter usually, x sub I, I starts from 0 for the left endpoint and doesn't go to the end for the right endpoint. And then for the Riemann sums, this is area of each rectangle where delta x is the weights of rectangle and f of the point, f of x0, f of x1, and so on. That's height of the rectangle. So together, they give you area of the rectangle. And the rectangle is so different. So you add sum, this Riemann sum means we're adding together. The sum means area plus area plus area plus area. That's exactly what I showed you in this yellow shape over here. Area of the first one, area of the first, second, blah, 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 approximation. The weights are all the same. That's why you can factor it out, but the height is different. The height depends on where the rectangle touched the graph of the function. Nice. Let me check the chat. And then, as I mentioned, let's work with logs a little bit. And after this, I'll feel satisfied. Because I saw some nice examples about logs in the review over here. And yeah, so actually timing is not too bad. Here, I saw log here, find the absolute max or absolute minimum. And I saw log again for the concavity stuff. So just make sure you know here, right? Just make sure you know how to work with logs. So let's do quickly each. Let's go down, and then we are done, so don't be afraid. So it shouldn't take too long. We have file. So copy the first one if you saw it, the very first problem. That's absolute maximum. I wanted to show it right away, but then I was afraid we're not going to have time, and I thought I will leave it till the end. 2 logarithmic problems, global max and not global max. That's number 1. I also have videos on this, that's why I didn't very worry too much about it. F equals 10x ln x minus 11x. And they ask you to find absolute minimum. So you know how to start. You all know how to start. They ask you absolute, local, doesn't matter. You start with finding the derivative. And then it's going to be 10 times 1 over x. No. Just that, unfortunately, that's not how you do it. It would be nice. It's a product rule. So you have to know the formula again, like we did before. Before we did product rule at the very beginning. U times V. So derivative of 10x is 10. Copy log plus copy 10x. Derivative of log is 1 over x. And don't forget minus 11. Ln x prime is 1 over x. Amazing. I'm very proud of myself. Now you know how to proceed. Z equal to 0. So and D and E. Those are your critical points. Step 1, derivatives. Step 2, critical points, critical values. Kind of looks messy. Let's simplify. 10 ln x plus, whoa, x and 1 over x got canceled out. How amazing is that? And then we have 10 minus 11. That's so nice. 10 ln x plus minus 1. So we're going to write down equals to 1. How nice is that? So that's called logarithmic equation. I actually have videos for pre-calculus class about logarithmic. Oh, it's calculus 1 as well. Logarithmic equations. Let me put it in the box. I have exponential logarithmic equation in my videos, log equation. The idea is the same. To solve a logarithmic or exponential equation, you need to isolate log or x. So if you're stuck, just remember that I said in the very annoying voice with the accent, isolate ln x or e to the x. It's going to be 1/10. When you finished isolating ln x or e to the x, you apply the other function to it. If it's ln, apply e to both sides. If it's e, apply ln to both sides. That is because e to the ln cancel each other out, it actually means the inverse function, so they are undoing each other. X equals e to the 1/10. So for the log, answer will be e to the right-hand side. For the e, answer will be log of the right-hand side, where right-hand side is, in our case, 1/10 CP. Guess what? There were no D and E points that are in the domain of the original function. I mean, x cannot be 0 or negative. Okay, so that's my CP. And that's the answer. So again, you're supposed to check it is the answer. They ask for global, maximum, global, minimum. Well, first of all, they say it exists, so it's there. We only found 1 point. You know, that's the answer. That's global. Global minimum. This is global minimum. But actually, you're supposed to check, and you can check using first derivative test or something like this. First derivative test is the best one in this case. Sine line, and you put your f prime, and you put this e to the 1/10. And again, if you don't know how to use test points, you maybe put it as 1.105. But now I want to use test points like 0 and 10. Oh, but if I use test point 0 and 10, I will have to plug it into my derivative. My derivative is this. Maybe I should write it down nice. F, let me put it in green. F prime equals 10 ln x minus 1. So don't do what I just did before. Make it actually nicely looking table so you know where to plug. I'm plugging into this. If you choose 0 as a test point, you will end up ln of 0. And you cannot do that. You cannot plug 0 or negative numbers into log. In general, the moment you see this function, that means x have to be positive. There's just no choice. So unfortunately, this interval for f prime and f original one has a left side. It's open and it's 0, so you cannot use it. Oh, it's fine. Use 1 because e to the 1/10 apparently is bigger than 1. So that's legal. Or you can use e. I would use e for the right test point. Anyway, it will be minus and plus. Actually, again, instead of 10, I would use e over here, because then it will be nice to calculate ln of e over here. ln of 1 is nice, and ln of e is nice. Derivative is negative and then positive. Original function is decreasing and increasing. This is your minimum. But how do we know it's global minimum, not the local minimum? Well, actually, because it's the only critical point. There's no other critical points. It cannot change direction, so it's also going to be always minimum. That's how can I explain it? There's no other point. In order for function to change direction to get another minimum, it has to have more points. And there's no more points. It's only 1 point. Thus, it changed direction once and keep going forever. That's the idea. So this x gives you global minimum. If they ask to find the point, answer x, y equals, that's global minimum. Input is e to the 1/10. Output is, you have to plug it into the original function. In the original function, if they ask, I don't know if they ask me, 10 times x e to the 1/10. ln of e to the 1/10. That's 1/10 for you to know. ln is undoing e. Minus k11 e to the 1/10. Like so. Actually, it's not very hard to calculate, to be honest. That is, input is e to the 1/10. This guy is 1/10 itself. 10 and 1/10 cancels it out itself, and the answer becomes, comma, e to the 1/10 minus 11 e to the 1/10. But e to the 1/10 minus 11 e to the 1/10 is minus 10 e to the 1/10. Or you factor out and you can see minus 10 e to the 1/10. Whoa, look at that. I can just calculate it. That one is nice. Oh, and I wanted to show you that. Let me check the chat. Local minimum. Oh, it's a very good question. It's local minimum and global minimum. Yeah, local minimum. Local minimum is local because on this like small interval is the smallest point. And then when you zoom out, it ends up to be the only local minimum. So if it's the only local minimum, then it's global minimum. That's a very good question. Yeah, very smart. Now, so the other one I wanted to show you was this weird one. It's not weird, it's just I already know it will be lots of work. You also, oh, I wanted to mention that you see this phrase, let me zoom in, like here it is. It's called Rolle's theorem. So it was on the exam, I deleted it. I never give Rolle's theorem on my tests for Calculus 1 class. The students just don't do well. So you can see that. I just deleted it all completely. No Rolle's theorem. It's a nice theorem to know, but I don't like testing on it. People just don't do well on that. So now you know that. And I wanted to check. Where's log? Here it is. Can you do the same thing I just did, but actually find concavity? Number 14. Let's maybe quickly do it. Can you figure out if it's concave up or concave down? This one will have a fraction. That's why I wanted to show you. Because ln looks nice, and then you differentiate, it becomes 1 over x. And 1 over x gives us weird fractions. Number 14. Number 14, I found it. Let's just quickly proceed. Perfect. I think after that, my tablet will not handle it more. So it's nice. It doesn't like to go over 2 hours, my tablet, I noticed. Number 14, they have f equals 5x minus 2 ln x. And they even tell you that x is positive. Well, duh, because if you have ln with x as an input, that's it. That means x has to be positive. Use interval notation to find concave up, concave down. Okay, let's do that. But in general, can you do everything? Can you find intervals of increasing, decreasing, points of inflection, critical points, and then concave up, concave down, and points of inflection? Can you do all of this? So solution. Start with the first derivative. You can call it f. I like to call it y, which is actually not right. It's not necessarily y. Maybe it's g, but it's fine. Y prime is 5 minus 2 over x. Whoa, how did we get that? Well, let me remind you. And then x prime is 1 over x. So when I have 2 ln x, that's going to be 2 times 1 over x. And I just remember this like 2 over x. Why not? And should we solve? I guess let's find. Oh, my table got dark suddenly. 19. Okay, it should be fine. Oh, let me close everything. Oops. Good. So let's find everything quickly. That means increasing, decreasing, then concave up, down point. So set it equal to 0, and don't forget d and e. And that's kind of the new part here. You have 5 minus 2 over x equals to 0. My suggestion, create common denominator, always works so much better than moving it around. I don't recommend you to have 5 equals 2 over x and then solve for x. You will lose the d and e points, and sometimes the important. So it will be 5x minus 2 equals to 0. Now, the top gives you good points, which called I forgot the name suddenly. And the bottom gives you bad points. That's called singular points. Remember singular points because singularity means bad. Singular point. Singularity is when some weird behavior happens. You probably heard about in physics already. Singular points. Forgot the name of the first one suddenly. It's non-singular points, but there's a name for that. Oh, stationary. I remember. Stationary points. You don't have to know that, but I'm just letting you know. So x equals 2/5 is my critical point, question mark, and x equals to 0 is my critical point, question mark. To find out, you need to check if it's in the domain. Remember that. Domain, question mark. What is domain? Well, logarithm is involved. Domain x have to be positive. So domain is actually 0 plus infinity. or basically x has to be positive. Is 2/5 positive? Yes. Is 0 positive? No. So you have only one critical point. Answer 1. Critical value is 2/5. If you want to find the output, plug it into the original. Continue. Step 1, find derivative. Step 2, find critical points. Step 3, if you want to find increasing decreasing interval, you do the first derivative test. I call it sine line. It's not my idea. Put 2/5 on the thingy here. Don't go to the left more than 0 because there's a restriction on the left, and you don't use 0. So it's a test point. And I use some test points. 2/5. Is it bigger or smaller than 1? It is smaller. So I will use 1 on the right. And then I will use 0.1, for example. Again, I don't have to have specific numbers, exact numbers. I just want to know the sign, positive or negative. Let me plug 1 into the original derivative. What is the original derivative? This one or this one. Choose which one you like to plug in. If I plug 1, 5 minus 2 is positive. Nice. If I plug 0.1, see, 2 divided by 0.1 becomes 2 multiplied by 10. 10 is bigger than 5, negative. That's how I see it. The original function then is decreasing and then increasing. And you can write down the answer. Answer 2, decreasing on the interval minus infinity, find the mistake, to 2/5, increasing to 5 to plus infinity. That is not correct. That's going to be a trick. Oh yeah, but like be careful with that. It's not from minus infinity. So when they told you that x is bigger than 0, you have no right to write down minus infinity anymore. It starts from 0. So that's going to be a mistake. From 0 to 2/5 to 5 to plus infinity. Yeah, good. CP. Oh, we already answered in the answer 1. And now we go to concavity. Step 4. Step 4, find second derivative. Let's use y prime prime. I don't remember the first derivative. Let's go back. First derivative, you can either use quotient rule or you don't. So basically you decide. I will use the first box. Derivative of 5 is 0. Derivative of minus 2 over x is plus 2 over x squared. Oh my goodness, how did that happen? Let me show you. Y prime equals 5 minus 2 over x, which can be written as 5 minus 2x to the minus 1. Highly recommend to do that to avoid mistakes. I'm doing it fast because I did it a lot. So I just recommend to avoid mistakes, because why not? Was it 5 or 5? Yeah. Second derivative. Oh, I have a mistake in my notes. The derivative of 5 is still 5 in my notes. How smart is that? Yeah, I should fix that. So I got distracted, but basically minus 1 goes down, cancels the other minus 1. 2 stays, and x becomes raised to the minus 2. So minus 2x minus 1 prime becomes 2x minus 2. I recommend writing it down as a fraction because you need to repeat the whole process. D and E and 0. Guess what? 2 cannot be 0. Isn't it crazy that 2 is not 0? Like, who said that? That means there will be no solutions. If there's no solution, there can be no points of inflection. But does it mean there's no concavity? Yeah, that's not how it works. You still need to figure out the concavity. Step 5. Well, step 5, let's do answer 3. No, answer 3 will be the concavity first. Step 5, you still draw a sine line for the second derivative. And you just don't put any point on it because we did not find any solution from this equation. So you still put 0 in your domain for the original function. But also x cannot be 0 in this case too. And then you choose any test point. Remember, we just need a test point, right? So choose 1, why not? That's a test point. Next one. When you plug 1 into the second derivative, it is positive. That means it's positive everywhere on this interval. That means it's a smiley face for the original function. That means it's concave up. You can check, you can plug 10, still positive. You can plug 100, still positive. Whatever you want, wow, still positive. So that kind of explains my answer here. Answer 3. Answer 3 says concave up. Concave up everywhere in the domain. That's from 0 to plus infinity. Make sure you remember that x has to be positive. Concave down, nowhere, none. None. People also say nowhere. Nowhere. And mathematically we say empty set, 0 with the cross. That's why you're supposed to do 0 with the cross unless you talk about empty set. Now you learn this in discrete math and logic. Points of inflection, poi, none, because it never changed the concavity. So that's again good enough. What do you think about this? All of this 2 hours and 20 minutes of stuff. It's good. To be honest, I covered everything I wanted. So it's just good. Read the applicational problems. Be good with those fencing problems. Derivatives, it's must do. You have to be good with the derivatives. First derivative, second derivative, increasing, decreasing, concave up, concave down. Those problems will be expensive and tiring. They're already on the test. So basically a problem like this one, it's not a secret. We put this stuff on a test. It's just we change the function, you know. But look how big it is. It has 5 steps, right? 5 steps, 4 answers. It's 5. Yeah. And you have to know it all. That's the thing. So make sure you're good with this. Those like very classical long form. It's called analysis of the function. The good news, they give you partial credit. So if you messed up something, but you did not mess up something else, you get partial credit for that. Learn how to read problems quickly. I explained in my videos as the English as a second language. In my case, it's a third one. Read fast. Numbers, put them right away. Then read what is it? Side, area. Which one is it? If I see square, I know that's not going to be side anymore. The dimension is higher. Feet squared means area. Feet cubed means volume, right? So that's how I know also from those kind of little things. And I see dollar. Okay, dollar, that's a cost function problem versus, oh, I never did the other one, right? Yeah, I have so many videos in that. But the other problem, definitely have to do it. Number 17. And the other one is when it's not going to be a cost function, when it's optimized area. Also a fence problem, X and Y. But they ask you to maximize the area. Maximize area when they gave you material, right? So they gave you given material used, say its perimeter for you to know. P is given. So 2x plus 2y is given. And they gave you some number, say 500. So you went to, for those kind of problems, it's again fencing problem, fence. But in this case, they want to maximize the area. This is the problem when you went to when you went to Ace store. When you went to Ace store and you saw a huge discount and you got 500 feet of material, then you came home and you're like, well, now I want to use my kind of material and I need to have a nice rectangle. So you don't want to have a leftover, and you don't want to have leftover of the material, and also you don't want to have an excellent gap. That's kind of the classical farmer problem. That's how you calculate. It's actually very realistic. My dad built houses, and that's exactly how he would build houses. You have material, and you know what area you want to cover, but you want to maximize it. So that's what you do. And it ends up to be area this time. It's the one that needs to be optimized. Here's your model, and you repeat the whole problem. You solve for x, but now it's from this first equation, right? So blah, 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 plug it in, differentiate, that's the answer. You know what my students noticed in one of the classes? If there's no restriction on the fence, so there are exactly 4 fences, Some problems have water. You can see it in my videos. Then there's only 3 sides of the fans, blah, blah, blah. If there's no restrictions like that, the answer is always 500 divided by 4. They just noticed that it's divided by 2 and divided by 2. You can check it in your homework. It's true. One of the sides becomes 500 over 2 and over 2. And it's a square. Because guess what? Optimal area is always a square or a perfect circle, unless you have restrictions. That's why lots of shapes we have are squares. Your watch on your hand is a perfect circle, unless you want to put some jewelry and they make it an elliptic. Your eye is a sphere for exactly the same reason. Well, it's almost perfect sphere. The ladybug is also a hemisphere because it's biological advantage of the perfect shape. And so on. You can also see that all the windows used to be squares, and then they decide to make tall buildings, and then decide to do taller square, which are rectangles, to have more light into it. Also, the stadium is supposed to be circle, but it's not because of the game and stuff like that. That's why it's elliptic. And also a running stadium is also elliptic because of that. But optimal shapes are squares and circles, cubes, and spheres. Lots of biological applications on that. That's it, folks. I guess good job for coming. People are still here. Look at that. Like so responsive. Lots of people still here. I'm very happy that you came. My voice is done, so I definitely need to start talking. Now it hurts a little bit. But just review this. I will post this video in 2 hours. It takes 2 hours for it to settle up in my cloud. And review it. But again, you're not supposed to watch me doing things. You're supposed to pause on this moment when I just describe the problem. No, even not here. When I just describe the problem, you pause it and you start solving this problem. Your next problem, you don't see me solving it. You pause, solve it yourself, play, see how I solve.
Thank you.
Oh, you had about extension after conclusion. Let me stop recording so I don't mess up the video. Let's see. Thank you. Have a good day.